there's supposed to be like a second part to this, and the part that plugs into the computer.
I think so, yes.
Not that they can work in that anyway, but
It's just fine. Yeah.
this is really advanced. Now let's see potential for my copy. But we cannot re-identify the one of the right shift key on the left side of the keyboard. There's two keys. Yeah, it doesn't matter. You can do the regular.
Oh, it's the position. Okay, sure. I can do.
It actually works. This is really surprising. Yeah.
So I'll put you right after the capability information draft, the working group draft. I'll put you, okay, yes, you we have the capability information model.
Yeah.
I can stress them.
Yes.
Afterwards, I'll do the NSF basic,
Yes.
and then I do the capability.
Yeah.
Okay, yes. So we're in the right order.
Yeah, for sure. Put up. Okay, I think we should start because we want to have time to get to the social in time. So I'll start moving the blue sheets. Okay, so welcome to the I2NSF meeting. I'm sure you've seen the note wall before. It still applies. If you're not sure what it means, ask your lawyer. So we've got the charter in this link, mailing list. Linda is taking notes.
Oh, Frank, thank you very much.
Yeah. And do we have a JavaScribe? Yeah. You'll never know. So, anybody volunteering to be the JavaScribe? Okay. Anybody volunteering to be the JavaScribe, Tim? Rich? It's fine because we just need if anybody wants to relay a message from the job room. Okay. Thank you, Rich. And the blue sheets are going around. And just so you know, they are now scanned and published online. Okay, we have a link to the agenda, job room, and don't forget to state your name clearly and slowly at the mic. Okay, let's start with agenda bashing. Does somebody think we don't have enough items on the agenda? Right? If you'll notice, we don't have an AD in the room. That's not intentional, but she has to present somewhere else, so she'll join us a bit later. Okay. Milestones achieved. We've had an RFC published, RFC 8192, the problem statement and use cases. IETF last call completed on the framework document. And we have new working group drafts, the I2NSF applicability, I2NSF capability, and the SDN IPsec flow protection. Oh, sorry. And so we've got three new drafts adopted: the applicability, the capability, and the IPsec draft. Current working documents until we finish the milestone is the terminology and gap analysis. And we have to decide whether this is ready for working group last call, the client-facing interface requirements. There are also a bunch of adoption candidates. We'll get to that later. So, could you cover this part?
Okay, so so this working group primary deliverables are the information models and data models, and here are the current drafts. And we have capability draft being the working group draft now, and along with that, there will be there are some others like the client-facing one, client-facing information model, and the registration information model. And we also have monitoring information model. So there's also the security policy objects. So those need to work with the, together with the capability draft authors to make sure they are consistent. Maybe if there's any missing information can be merged into, or maybe there's some additional information need a separate draft that may need to be discussed further. And for the data models, right now we have several drafts on the data models. And yesterday we had authors of the capability draft together to discuss the missing points and make sure of capability drafts. So we decided that the first thing is to work with the NSF facing data models, make sure the data model consistent with the capability draft information model. And then our next one is going to work with the client-facing one. And so tomorrow afternoon is the one we're going to discuss, the NSF-facing data model with the capability information model. Okay. And
okay, so let's. So, like any working group, we have a wiki, and this can be used for sharing resources, and you're welcome to update that. Okay, so where do we?
We're going to the
Which one is first?
hackathon.
Oh, yeah, the hackathon. Okay.
Hackathon. Someone in the room? Okay.
So many. No, this is no hackathon. Yes.
You can use this.
You can use this, or just tell me to.
Hello. Hello, everyone. I'm Sang-Won Hyun from Seongkyungwan University in South Korea. Can I put? Okay.
Go ahead.
Yeah. So in this meeting, Paul didn't come here because of some conflict on his schedule. So I will give you a brief report about I2NSF hackathon project. Yeah, so as you know, I2NSF uses netcomp, lastcomp, and Yang data model to provide standard interface to manage heterogeneous network security function. So in this project, we try to verify this concept of I2NSF framework is feasible using various open source softwares. So this work is a student project which involves 7 graduate students at Seongkyungwan University. So this is a hackathon poster. I just want to show you for reference. And in this hackathon, we try to extend I2NSF, the existing I2NSF framework implementation with the following. So first, we implemented consumer-facing interface based on REST-comp and Yang. Second, we implemented a registration interface using netcomp and Yang. And third, we implemented service function chaining based on network service header and tunneling protocol. So this is what we used in this implementation. And this is the network configuration of our I2NSF framework component based on SDN network. So to implement consumer-facing interface, we used REST-comp protocol and Yang. And to implement REST-comp protocol, we used JetComp. So basically, in our implementation, I2NSF user specify high-level security policy in XML like this. And then I2NSF user send the high-level policy in XML to the security controller using REST-comp protocol through this REST-comp server. And then we implemented registration interface. So using we implemented this registration interface based on netconf and Yang. So this developer management system is responsible for registering each NSF. So for example, to register a firewall, this developers management system send the capability Yang data of this firewall in XML. So for example, this capability Yang data may specify IP address inspection and port number inspection, something like this. And for this capability Yang data, we used this capability data model. And as a second example, to register this web filter, similarly, this developer's management system delivers the capability Yang data, in this case, URL inspection capability. And this Yang data is also described in XML based on this data model. And to implement service function chaining, we used network service header. So we attach this NSH header to the original packet. And to support forwarding the packet to this NSF firewall or web filter, we used tunneling protocol, which is generic routing encapsulation. So this additional header is attached in addition to this NSH. So this packet is forwarded to the NSF and first arrives in this SFC proxy. So SFC proxy and SFC proxy is required to support some legacy network security function. So this SFC proxy detach this yellow header field and forward this original packet to NSF for security inspection. So to forward the packet to another NSF, the similar procedure is repeated. So this SFC proxy attach back this yellow header field and forward to SFF, and SFF forward to the next NSF. So we implemented such functionality for chaining multiple types of network security function. So we uploaded our code in at GitHub, so you can download our code from this URL. And so through this I2NSF project, we keep trying to verify the feasibility of I2NSF project using open source. So these types of open source, we keep trying to verify the concept of I2NSF framework. So at this time, we got awarded with the best student project. So yeah, that's all. Any question or comment?
I have a question.
Yeah.
I noticed that you have this client-facing data model. Is that to the controller or is that to the SFF function? Like
A client-facing interface? Actually, that is between
The
I2NSF.
user agent and
the user.
Oh, yeah, user to the security controller.
sorry, I should have let you speak. I wanted to simply underscore how impressed I am that you're pressing the technology forward on the registration. That's usually a very key point in a network for making it manageable and deployable. And I want to thank you for that
Thank you.
leading edge work. Thank you.
Thank you very much.
Hi, Diego Lopez. Just is a question regarding which are your plans with respect to this project and the future. I mean, do you plan to update the code as the specs evolve, or is this a student program that you have stopped? Maybe you will consider in the future to continue.
Yeah, in the future, we keep trying to extend our hackathon implementation. So our main plan is
To come to London.
integrating OpenStack to integrate network function virtualization environment.
OpenStack here.
I'm sorry.
OpenStack.
Yeah, OpenStack. Yeah.
Okay.
So in this implementation, we try to outsourcing the network security functions to the OpenStack environment.
Wow.
Yeah.
No, but this is something we need to talk later outside of here.
Okay. Thank you. Thank you.
Thank you. The next one is SDN controlled APSec. Is Gabriel on the line? No? Delay that. So the next one is you again. Someone. It's the applicability of the. Yes.
This is Sang-won again. This presentation is about applicability of I2NSF. So in this draft explains general security service procedure in I2NSF framework, and we also explain several use cases of I2NSF framework. So in this presentation, I will first explain general security service procedure in I2NSF framework. And as an example, I will introduce time-dependent web access control security service scenario, which involves firewall and web filter. This is just a brief overview of I2NSF framework and its interfaces. So we have a set of information model and data model draft for each of these three interfaces. So this slide is about general security procedure in I2NSF framework. So in the first step, I2NSF user specify high-level security policy, which is about security requirement they want, and deliver this high-level security policy to the security controller. Then the security controller analyzes the received high-level security policy and identify what kinds of security capability are required to enforce this high-level security policy. And then the security controller identify specific NSF of the required security capabilities. Then the security controller generate low-level security policy rule for each of the required network security functions. And then security controller send the low-level security policy to each of the network security function through this NSF-facing interface. And then network security function enforces low-level security rules to incoming packet to eventually enforce this high-level security policy requirement. So in this slide, I'd like to introduce general use case of time-dependent web access control. Actually, this scenario is the security service scenario we implemented in our hackathon. So in this scenario, we assume that an enterprise network administrator wants to block every staff member's access to Facebook during business hours. So in this case, a hypothetical example of high-level security policy is something like this: block the access of staff members to Facebook from 9 a.m. to 6 p.m. So I2NSF user send this high-level policy to the security controller, and security controller analyzes and identifies the required security capability. In this case, IP address and port number inspection capability is required, and this capability, we assume that this capability is provided by firewall network security function. And another required capability is URL inspection and time checking. So we assume that this capability is provided by web filter network security function. And then the security controller generate low-level security policy rule for each of firewall and web filter. Then security controller send the low-level policy to firewall and web filter. So if a staff member try to access Facebook.com, then the traffic is first forwarded to the firewall for basic inspection. So in this case, firewall check the source IP address, whether the source IP address is staff member's IP address or not, and also check port number to identify these packets of HTTP protocol. So if two condition matches, then this packet, this firewall triggers web filter for more inspection. In this case, URL target URL inspection. So if this packet is forwarded to the web filter, then web filter check the target URL is facebook.com or not. So if this condition is satisfied, then web filter drops the packet. So this is the scenario of time-dependent web access control. And another thing we explained in this draft is integrating I2NSF framework with software-defined networking technology. And this integration can optimize the security service procedure by dividing the security policy enforcement into SDN switch and NSF. So specifically, SDN switch can be utilized to enforce simple packet filtering rules, whereas NSF is used to enforce more complicated security inspection. So this figure is illustrate this dividing the security policy enforcement into this switch and network security function. So in this newer version, we have revised section 3 to explain time-dependent web access control scenario, and in section 4, we explained the motivation of integrating I2NSF framework with SDN. And we also revised section 4.2 to explain the security service chaining using SFC for this VoIP, VoLT security service scenario. So in the next step, we will add additional use cases of I2NSF, and I wonder the next plan is probably working group last call in the next IETF meeting. So yeah, if you have any question or comment, yeah.
Yes. Is it working? Yes. So Arnaud Tadei. Question I have is regarding the slides before, on when you are looking at your use case a bit before. Yes, here, no, just after. So I understand you can access the IP address, but how are you going to access the URL at this stage? Where do you read this information?
Actually, this capability information is not given information to the security controller. Actually, by analyzing this high-level security policy, security controller automatically or intelligently identify the required security capability for this high-level policy.
So I understand that, but I don't see how, and even worse in the future, you're going to access the URL in the clear. It will be encrypted. So you are not going to be able to implement your feature to say, I want to block this URL from 8 a.m. to 6 p.m. because you will not be able to access this URL. Perhaps the domain, but not the URL.
So you mentioned the case when the traffic is encrypted.
Yeah.
So in that case, NSF cannot see through the inside. So actually, in this current implementation, we haven't considered that encrypted traffic yet. So we will think about that issue later.
Right, but it's going to be 80%. Perhaps today is 70% of the traffic today. So it's going to be even worse in the future. So you really must look at that. Otherwise, it's going to be very limited use case.
Yeah. In this case, yeah, definitely, we need to a certain way to decrypt packet or to look inside the packet content. Yeah. So
which will conflict with what the TLS groups is trying to do, but that's an interesting challenge.
Okay. Thank you for the comment.
Okay, go ahead. Just one comment. Didn't capture your name. Maybe you can go to the notes, the Etherpad. Etherpad, you can enter your name there.
Sorry, my name on the list, you mean?
No. There's an Etherpad. They can. Your name. Yeah, just say your name then.
My name is Arnaud Tadei.
Ok, Cataldo Basile. I have a few questions on the way the policy refinement works, because I want to know what part of the refinement of this high-level policy into low-level policies are coded in static information like Facebook, time, and what is the part that is intelligently, smartly made by your policy refinement system. And then I have also another question about the capabilities. How can you tell the actual difference between a firewall from a packet filter from the Cisco firewall, or for the, I don't know, from another brand, the Checkpoint firewall, when you have to implement? Because firewall is a very broad, and this is just a label, and we are trying to address this with the capability model with the other one. And the third point, maybe if you want to first answer the first 2 points, maybe.
Yeah. Actually, this is an example of high-level policy. So in this case, I2NSF user doesn't have to worry about the specific IP address being used by STEM members, something like that. Yeah, yeah. So this is how this is a user-friendly high-level security policy. But from this policy, we cannot directly apply what we want. So in this case, the security controller need to identify the IP address being used by STEM members, something like that. Yeah. So that is the part of the translation.
My question was how is the inside of the security controller made? How can you map the high-level policy into the low-level security policies? So how you actually do this? Because we are also working on a similar thing, and we are using different methods and forward inference logic and some mapping with ontologies, and it's a lot of work we are doing on this. And I want to ask you, how did you actually implement?
Actually, currently, this high-level policy to capability mapping, we don't have very specific or solid algorithm yet, but conceptually, this kind of mapping is very important in the security controller. So, we need to think more about how we can translate. Yeah.
And then so I thank you for the answer. And then for the security controller, so when reading the other draft from the I2NSF documents, the security controller has different functionalities, but there is no explicit request of having a policy refinement engine inside the security controller. So I want. So this is an open question, probably for the group for the future discussion. Is the security refinement engine a part that must be inside the security controller or an external component? Because in my understanding, so at the network layer, the policy refinement is outside, while you incorporated in a single box the security controller. And then there is all the management of the loading the network security functions, pushing the configurations, and this is everything up to the security controller as intended by this working group, and the policy refinement has never been explicitly indicated. So that's my doubt at this point.
I just want to add some comment to that. You're questioning about the internal brain. How does a controller translating from the user level to the NSF facing, right? There's an open source a project on that by Linux Foundation called Open Security Controller. And their goal is to actually started by Intel. And that is where they want to have open source code and translating from user intent policies to more specific function level policies. So something we can look into.
Okay, thank you.
If I may, Professor, some of the original work we did there, is it hearable, guys? Or did it quit?
it's hearable if you talk to the mic rather than to the back.
It probably, oh, there it is. Okay. So I can hear. So probably that in all the other things in the ITF that are management and routing and some of the other, that internal piece is actually per implementation. So it won't be found in the data models that you're seeing, NetComp, ResComp. It's extremely important. It's just, I just wanted to say you won't find it in the data models. He may have it, the open source may have it, but it's specifically not there.
Thank you.
Okay, yeah, thank you.
Okay, thank you. Gabriel, you're next. So if you can raise your hand in the Meet Echo room, so I can. Yeah. Okay. Thanks. Just a minute. So yeah. Right. So if you remember, in previous meetings, we always had some people from Mercer University, I'm not pronouncing that right, coming and having their draft for controlling IPsec. And we've always had the IPsec mafia, well, I was part of that, coming in to say, no, that's a terrible idea. We shouldn't do that because they don't understand how VPN works. So in between these two between the last IETF and now, we had a virtual inter meeting where we discussed this, and as it turns out, the scope of what they're doing is really separate from the traditional VPN, traditional IPsec VPN that we're also concerned about. So we reached agreement and we adopted their draft, and now Gabriel is here to
Can you hear me?
talk about that. Okay, so Gabriel?
Yes? Okay, thank you.
You're up.
First, sorry for the delay.
Yes, very well.
Well, my name is Gabriel Lopez. I'm going to present the work done together with Rafael Marin about the HDN-based IPsec flow protection. Next, please. Well, just a quick summary. In the draft, we define an architecture for the SDN-based IPsec management. The idea is to define the framework, to centralize the establishment of security associations from the security controller, and also to define the NSF-facing interface required to manage and monitor the security association, in this case the IPsec security associations, in the network security function element from the security controller. In the draft, we proposed two cases. In case one, we suppose the network security function implements all the traditional IPsec stack, including the kernel elements like SPD, SAD, and PID, but also the key management protocol, in this case, A-key. So in this case, the security control should be able to provision the network security function with the information for the A-key, SPD, and PID elements, not the SID, because the security association are established, in this case, after running I-key in the network elements. Also, in case we define a case two in which we suppose the network element implements only the IPsec databases, that's it, the SPD and SID, but no I-key in the network elements. So in this case, the security controller should provide the network security function with the entries for the policies in the security policy database, but also the required information for the Security Association database. Okay, next, please. Well, from the last version of the draft, we have done some little updates. In section 5.3, in case 1 versus case 2 discussion, we have included some text about what happens, what could happen, just to introduce the problems of what happens when the network security function restarts, the behavior of the network security function, because it may lose part of the IPsec state. So, well, it's just a way to introduce the discussion, and we by default we suppose that the state in the network security function is lost, and therefore all the information has to be configured again from the security controller, depending on case 1 and case 2. But we can also think in other more optimized options, like can be considered like the configuration is permanent in the network security function between reboots, following the traditional way of running config at the startup config in the network security function. Next, please. Yes.
Do you take questions here now or later? Okay, this is Tero Kivinen. If you go back one slide. One of the things I actually really, I'm one of those IPsec mafia people. So one of the things that really worries me there is again saying, assume that all states may have been lost or something like that. And
yes,
it says that you have to send. If you are using case 2, you can't send anything, you have to recreate it, because you are already saying that which means that you have to send, you have to recreate it and send it to every other peer that this one talks to. So it's actually, this text here is really scaring me, because it's not, explaining it properly. It's just, we can just send some information, which would indicate that you have the information, but you don't. You have to recreate it. You have
to sorry. In fact, you are right.
It all the other peers and send it. So it's much
not
more
the best way to express
than
that.
just
but,
sending.
Thank you for the comment, and you are right. We have to. The idea is that the security controller has to recreate the information, mainly the more problematic case, as you say, this case too, because we have to, or the security controller has to recreate again the security policies and also the security association database. We will try to improve the text for the next version. Okay. Then we have made some changes in the Jank configuration data model, mainly following the comments received in the mailing list by, in this case, by Paul. Thank you, Paul Water, for the comments. The main changes were in the SAD model. We have aligned the description of the AH and ASP description just to be coherent with the description of the elements. We have introduced or in this case modified the combined encryption element in order to improve the description or how to represent the combined encryption algorithm by means of the authentication and encryption previous elements. We have also, following the recommendation of Paul, we have added the ESP encapsulation element in order to allow the representation of the ESP over TCP and ESP over TLS, because in the previous model we only allow the definition of ESP over UDP. And also we have added in this case a new notification is also following the recommendation of from Paul, the notification of bad ASPI. But in this case, I think we have included that in the Jan model, but I think that it needs a bit more discussion in the text in order to clarify how the security controller should manage this kind of bad ASPI notifications. Next, please. Well, regarding the Jan configuration data model, we have also following the recommendation from Paul, we have updated the auto startup element, which was previously a Boolean element. Now it's represent the states of always on, initiate on, and demand and respond only. We need here some text describing the states, the different states. We have added the encap element in order to allow the source port, sorry, it's a typo there, source port, destination port, and original address for NAT traversal options. We have also added the combined encryption element for IKEY. To allow also, following the recommendation from Paul, the list of PFS group, because in the previous version we only allow one PFS group. And also we realized that elements like in phase one authentication method was already defined in the PID, so we have removed that from the phase one element in IKEY version 2 model. And we have also removed from IKEY the, in this case, the lifetime auth algorithms and encryption algorithms, local and remote addresses, because we assume that this information will be represented by means of the ASPT model. Next, please. Well, the last change is following mainly the minutes of the interim meeting commented before. We have added a new security consideration section in which we assume that the of course, the security controller is the key point here, like in every HDNS scenario. We assume that in this case, the security controller has to follow the security requirements specified in the IETF100-I2NSF-20171114-1550 and the RFC 8192 documents. And we have also introduced some text about the problematic of how to avoid in this case the impersonation of the element. This text also needs to be improved. It's just a first version of discussion. We assume in this case, for example, in case one, the security controller has to send the IKEY credentials to the network security function. It could be public secret key, public private key, certificates, etc. We assume that the general recommendation is that the security controller never stores the IKEY credential after distributing them to the network security function. And yes, yeah.
I have a question about that. This is Terokivinen, okay. I have a question about that because you said that it's somebody needs to store this long-term credentials for long-term time Either it's going to be the SC or NSF. You say the NSF
Yes.
might store it in stable storage,
Yes.
but might not. So in case the NSF doesn't store it, then the SC needs to store it. So one end needs to be storing
Yes.
this because it's a long-term credential. So you can't say the SC never stores it. It doesn't store it if it assumes that NSF stores it. Or are you planning to say that you are creating new PSKs and public key, private keys every time you modify anything?
No, the idea is that
for example, PSKs, you have to.
should never store
PSKs might be configured also in other
credential,
devices that are not maintained.
the network security function in this case. Yeah.
Who stores then? Okay, but you say there it might store it might make the configuration permanent, but it doesn't say. But might doesn't mean that it always does. So you are assuming now that the
yes,
NSF
we also
always stores the configuration.
assume that the network security function must not allow the reading of these values once they have been applied. That's it's just to configure read-only operation in the network security function. And well, you have some ideas of how to avoid impersonation in this case in the A key element. If we are using PA's key, then immediately after distributing the PA's key, the security controller should remove it. If we assume that iKey is using raw public keys, the security controller should remove the associated private key immediately after distributing them to the network security function. And in the case the iKey element make use of public key certificates, one option could be that the network security function may generate the private key and export the public key for certification in the security controller. So before are just some first ideas to solve the problem of impersonation. Next, please. Well, in case 2, we have the same problem. The key material in this case are symmetric keys to protect the data traffic. Again, the security controller should never stores the keys after distributing them. And again, we assume only read-only operation in the network security function. Of course, if the attacker has access to the security controller during the period of time that the key material is generated, then he, of course, have access to the key material used in the distributed IPsec security association. This are some of the security considerations. I've said before, the text needs more elaboration. We have to include new security consideration, but it's a first approach. Next, please. Well, just to finish, some next steps that we have in mind. The first one is to continue with the revision of the configuration data model based on the comments from the working group, but also to start another important point, that is the state data model, in order to allow the security controller to monitor the behavior of the network security functions in both case 1 and case 2. And next, please. That's all. Thank you very much for your time. Sorry again for the delay.
Okay.
That's all. Thank you very much for your time. Sorry again.
Okay, thank you, Gabriel. So as there are no people running to the mic, what's the next? Not the one? Okay. So which one?
You just go to the. This one.
You mean the capability
Not this one.
Not this one? No,
That.
the one on the screen.
Oh, okay. Oh, you moved over.
I wish. There we go. Okay. Click.
You can click yourself if you like.
Oh, okay. You're assuming that I can figure out how to use this. Okay, so the capabilities draft was recently adopted by the working group. This is just a quick reminder of what capabilities is, and the purpose of this slide is to remind the data model authors that there's a difference between capabilities and events, conditions, and actions. Events, conditions, and actions are not capabilities. Next. Hey, it worked. Yay. There's a duality, however, between capabilities and policies. Capabilities describe functionality. Policies can be used to manage that functionality. They can be used to define a new capability. They can be used to combine different capabilities. So this network device consists of this set of capabilities. It can govern the different types of OAMP data that are not only exposed to different clients, but also define which OAMP data should be gathered in the first place. And that's enough about that. I'm going to try and go fast. The purpose of this draft is to ensure that capabilities are independent of the packaging, the deployment, and other characteristics of both physical or virtual NSFs. We used an object-oriented information model to maximize interoperability. Even though the IETF is very interested in Yang, there are plenty of other applications like cloud that don't use Yang. So in the future, if we want I2NSF adopted, we need to keep that in mind and be able to produce other types of data models that have a common definition and a common semantics with the Yang models that this group is producing. So just to be clear, I'm not saying that we should produce, for example, a relational calculus model. I'm just saying that other people might want to. The current ECA model and capabilities actually have two different parents. So capabilities are a type of metadata. Policy rules are a type of object in the system that metadata can describe. Not only can metadata describe the policy rule as a whole, but metadata can be used to describe the component parts of that policy. I can have metadata for events that is very different than metadata for conditions, that is very different than metadata for actions. The behavior that we have right now is what we'd call simplistic but still powerful. So if an event fires, it is represented as a Boolean clause. So if time is greater than 8 in the morning and user is not authenticated, that would be two terms in a Boolean clause that gets evaluated. If the Boolean clause evaluates to false, next rule, we're done. If the Boolean clause evaluates to true, then we evaluate the condition. So the event can be viewed as setting the context. The condition is now what you would call the selection of the applicability of the actions in that policy. So now we've got, it's 8:01, John hasn't been authenticated yet. The event Boolean clause returns true. We now evaluate the condition, and that condition can have any number of things from any of the packet headers as well as other data. We could have IP fixed data, we could have other types of data, and if all of that is true, now we are ready to execute an action. Note that I didn't say we will execute an action. That depends upon metadata and a resolution strategy. So if I had 5 rules, my metadata might, for example, say, execute the first rule you come to and then return. It might say execute the last one, because we all know from ACLs that order is kind of important. It might say execute every rule until something fails and then do something else, et cetera, et cetera. So this metadata, this is an example of what we call prescriptive metadata that applies to the rule as a whole. You can also, of course, have descriptive metadata, like, for example, best current past practices. The resolution strategy is defined by a formal algebra. We all find it fascinating reading. We'd like some comments from the working group. That's a hint, by the way. We're going to enhance this, but you'll have to read the next draft to see how we enhance it. The biggest contribution of this algebra is that detecting conflicting policies is really hard. I've graduated 3 PhD students whose theses were about policy conflict detection and remediation. And it's still not solved in the general case, I promise. So this capability algebra is a very simple and hopefully not computationally complex, at least we don't think it is, way to determine if 2 or more policy rules conflict, i.e. their event and condition clauses are both satisfied, but their actions do 2 different things to the same object. That's a bad thing. So conceptually, we have an NSF. Is there a... That's not it. That's not it. That's not it. Okay, this wins. The aggregation, which is the diamond with the 2 lines from NSF to security capability, is UMLEs. For an NSF aggregates or is described by a set of capabilities. Question?
Yeah, just a question. So how do you, Daniel Migo from Ericsson, how do you solve the conflicts between policies when they're expressed with ECA?
So the question was, because I could barely hear you, so I don't.
Sorry.
No. I think it's the mic. The question is, how do you solve these conflicts since ECA conflicts are so hard? We introduce a number of control points, such as priorities, that allow for a deterministic solution. So, for example, if I have 2 rules, one says authenticate, the other one says don't authenticate. If the priority of the first is higher, it wins. Okay. There's some other mechanisms, but we could talk offline.
Okay, right.
Or Aldo, do you want to add anything? Mike.
I just want to add that the capability model is about what a network security function can do. So we don't fix the resolution strategy or the way the conflicts are managed. We just need to describe, in order for the security controller to understand how to manage the network security functions, what are the strategies available at the current function. So there is no the fixed, there are several ways as expressed by John, but in general, the capability model must just allow the vendors or the people using the system to understand what I can do with the security network security function. Then if you support, you can enable. If you support more, you can select. If you don't have an internal resolution or conflict resolution internally, you don't use it.
Yeah, and in fact, to generalize what Aldo just said, what we're trying to give you is a Lego building blocks. So we're giving you a bunch of building blocks to put together your policy the way you want to, because who are we to tell you how to build a policy, right? So that, so do take a look at the resolution strategy part in the draft and let us know if it meets your needs. So next steps for the capabilities ID, this is actually going to be a fairly large rewrite. It's going to be a large rewrite because we are going to move towards a more academically precise information model with guidelines on how to translate that back into English, so don't be scared. And so you can look at these and others as being implemented using UML, using wherever possible design patterns. And if we have time at the end, we'll talk a little bit about what a software design pattern is. I think the key thing to think of is that it's, if you think of events, conditions, and actions as templates and capabilities as contents that the templates apply to, then a policy rule is a template of templates. So an example of one of the patterns is the decorator pattern. Decorator pattern is one of the most underappreciated, underused patterns I know of. It was actually defined in 1995 in the Gang of Four's seminal book, Design Patterns. So that's 22 years ago. It's used in the Java I/O library and other parts of Java, in lots of other places. It is an alternative to inheritance. In inheritance, I start with an object foo, and I say if I need new functionality, I create a subclass of foo called bar. Well, that's fine as long as a number of principles are followed. It can also lead to class explosion. The simplest example I can think of is if I'm building a windowing toolkit and I start with a base object called a window, and I have a horizontal scroll bar, and maybe a vertical scroll bar, and a title bar, and a bunch of icons, on and on and on. If all of these are objects and I want to represent every possible permutation of them using inheritance, I take the permutation of all of those. That's a big number. If instead I use the decorator pattern, then what I do is I compose whatever type of window I need using all or parts of these other objects that are already defined for me. And not only does that increase reusability, but it dramatically simplifies the conceptual model of the software. There's also another set of patterns that we'll introduce. The question that we'd like the working group to ponder is, do you want one ID, which is going to be well over 100 pages? That's a hint. Or should we split these things out into a separate ID? Don't have to answer now. And that's it. Questions?
Seems to be.
Hello, Hank.
Hi, yeah. Hi, I'm Hank. This is I think the ideal way to do is start with a big document, and when you start to hate it, then you split it up. No, really, because if you would split it into multiple documents, it would, I don't know, be confusing to compare the patterns and see which is fitting to your purpose, which is not. And having that in one place, I think to start with is the better approach, the personal point of view only. And then when we realize that there are basically a distinct set of patterns that are well defined, we could create a pattern ID. But for starters, I would keep it the capability stuff.
That's an interesting opinion. I would note that if we had a separate ID, it would be easier for SACM to reuse that. But
yeah, that's made an iteration to that. I don't know. Maybe Dave would have an opinion to that. But did you spoke to Steve or Dave?
No, it's a good point of view.
Okay, but that's a good counter argument. I will ask Dave.
Okay. Since we're short of time, is there any substantive comments? I think we should move on.
Yeah, thanks.
Sorry, if I may have two questions. Excuse me. I have two questions for the former speaker. All right, so apologies, I'm new to this work, so I don't have the background on everything. So first question is, how are you approaching the access controls? Is this something you go down to that level when you want to specify certain functions to do certain things on access controls?
So do you mean a specific object-oriented implementation of RBAC or ABAC or something? That's not currently in the scope of this document. I can, if you're interested, I've built an RBAC and an ABAC OO UML model before, so I could point you at that work. That would, so those are, so RBAC and ABAC is really, and other types of ACs are really design philosophies, right? And so they're not really a capability, although you could define a capability that says, here is the access control models that I support on a contextual basis or even a per object basis. You could, of course, define policies to control the different life cycle aspects of RBAC or ABAC. But that's not what this draft is doing.
Okay. So second question is actually the language approach of the policy aspect. So, I mean, I looked at two products, one on proxy on the web and one on SMTP MTAs that had to go the path of describing a full language to actually explain the policies and then get them to implementation. So have you looked at specific implementations like this? Because the concern I would have is, are you sure that you're covering all what we're going to need with this approach?
I'm not quite sure I understand the question, but so let me take a shot and then maybe Diego.
I think this is better handled offline, especially because we're really short of time.
We can do offline. It's okay.
We'll do offline.
On the mailing list. Thanks. So next up.
Hi. Hi. I am presenter Jin-Yong Tim Kim from Sungkyunkwan University, South Korea. This presentation is about young data model for network security function pacing interface. NSF pacing interface data model is used to configure the security policy rules into network security function for automation. This draft is updated version from previous version. This draft defines young data model corresponding to the information model for network security function page interface. This young data model was verified through prototype implemented at IETF100 hackathon. This slide shows major change of this version. We considered capability algebra for net security policy rules, such as event, condition, action clause, resolution strategy mechanism to prevent conflict between security policy rules, and default action mechanism to take action if the rule does not have an action clause. Second, we considered consistency between capability information model and NSF pacing interface data model. In the case, we are ongoing. This slide shows consistency between capability information model and NSF pacing interface data model. Left figure show capability information model, and right figure show NSF pacing interface data model. In the left figure, subclasses of ECA policy rule can be inherited and used to define network security ECA policy rules extensively, so that other policy rules can be audited. Likewise, in data model, the subclasses of ECA policy rules can be inherited and used to define rules extensively. Also, subclass of event, condition, and action object can be inherited and define the object extensively. Likewise, in data model, it consists of event, condition, and action clause object. After event, condition, action clause object are made, the ECA policy rule can aggregate the object to reuse. This slide shows detail of the following slide show the detail of event, condition, and action class. This is about detail of event class. This is about detail of condition class. This is detail of action class. In next step, we will discuss with IEM and DM team for consistency between IEM and DM. We will verify Yang data model by implementing a prototype. We request working group adoption.
Hi, John Strassner. So in general, in looking at this latest version, I think you've done a very good job. There's a meta question for the working group. There's two very different ways of building Yang models. The first is what I'll call a traditional way, where it's basically just a hierarchical model, much like what you've done. The second is making Yang more object-oriented in spite of itself. And for example, even though Yang is not object-oriented, you can use Yang tools like a grouping and an identity to define an ID for an object that corresponds to the information model class. And this, in my humble opinion, solves a number of deployment problems that you'll have with Yang. So I think that we should discuss this in some future point, not now, and come to a consensus in the working group. Thanks.
Okay, thank you.
If I may just, I promised our presenter that I would also comment on some of John's comment. John, the Yang NetMod working group is actually taking that step, and the guidelines in the new Yang working groups would draw models into your suggestions. So I think, yes, you may be shocked and fall over because they're, your heart may stop now, but yes, I know, but they're actually moving in that direction. So I think that in doing our Yang models to work with the IETF, I would suggest that this working group would go in the direction of the Yang guidelines that align with John.
Thank you so much. And tomorrow afternoon, we're going to have more discussion on the detailed data model. If there's any inconsistency or anything not there, we're going to have more discussion, right? Tomorrow, right, John? Next one is the capability data model. It's also you, right? Capability data model. Yeah.
Oh, hi. I am presenter. From Songyungan University, South Korea. This presentation is about Yang data model for culpability. Culpability data model is used to register the culpabilities of network security function into security controller. This draft is updated version from previous version.
Sorry. So your previous slide, that's not correct. So the capability data model should not say anything about registration, right? The capability data model should instead be a reusable template of templates that describes the structure and organization of what a capability is.
Thank you, John, for that correction. It is really providing the information about the capabilities. We'll go on and let him present them.
Okay. This developed a young data model corresponding to information model for registration interface. This young data model was verified through prototype implemented at IETF 100 hackathon. This slide shows major change of this version. We considered culpability algebra for security policy rule, such as event condition action clause, resolution strategy mechanism, deportation mechanism. We have made it possible for vendors to extend this young data model according to specific capability of their network security functions. We added the examples in appendix. In appendix A, it shows extended young data model about a specific network security function for such as extended VoIP, VoIP security function capabilities. In appendix B, it shows configuration XML for generating network security function capabilities and extended VoIP, VoIP security function capabilities. Vendors can extend the capability young data model through inheritance if the capability young data model does not provide capabilities for network security, specific network security function of vendors. In the figure, as shown in this figure, vendor can extend the capability young data model through inheritance. In next step, we will discuss with IM and DM team for consistency between IM and DM. We will verify young data model by implementing a prototype. We request working group adoption.
One request for John that I should mention in this consistency model. We should look toward the very thing you just mentioned, the grouping, the things to work on that. So I just want to mention that John's earlier comment should be looked at in this prototype. If Frank, I'll put it in the notes since I got to take notes too. If it's confusing.
Okay.
I have a question. So what's the major difference between the capability data model and NSF facing data model? Because you are the author for both of them. What's the major difference?
I think in the case of capability young data model, we can use the capability young data model to register the capability to security controller. And in the case of NS-facing interface young data model, we can use the young data model to configure the network security function. We implemented the prototype at IETF 100 hackathon. This is good.
So to help you out, John, one of our discussions needs to be looking at the grouping you just discussed and see if we can have common grouping to reduce the complexity. And we started with implementation and now we need to look at that factor. Okay? I think that's what you were trying to help us do earlier, right? Yeah.
Okay. Thank you.
Thank you. Next one is the consumer-facing interface.
Customer-facing?
Customer-facing. Client-facing, yes.
Consumer-facing, yeah.
Okay, customer, yeah.
Hello everyone, it's Frank Xiang. Okay, this is a new version of this about the customer-facing interfaces of I2NSF functions. And here, the customer-facing means that the node-bound interfaces for the security controller. So the applications request his requirement or his end-to-end security service requirement to the security controller, and how we define this kind of service or requirement with information model style. Okay, so next page. Okay, so firstly, I will give an introduction of the major changes in this version, and then some more details about how is the current information model design and the next plan steps. Okay, next page. Okay, before I give the major changes of this draft, I want to say that actually the original idea of this customer or this client-facing interfaces information model is from some enterprise users from the Europe and United States enterprise users. So we get a lot of information input from them. So help us to get a lot of get the enough content for this information model. And then we have the customer-facing requirement drafts, which is a working group draft now. And then based on that requirement draft, we have write this information model draft. But from my personal view, that I think that current information model draft it's not it's not so formal, you know. It's more like some content that we need, and we list here, and we organize them into some simple structure. But I think later, after the work, we compile this customer-facing model to the capability information model, agreeing that by our working group that the basic information model. So we need to reorganize the information model, so make it more consistent and more formal. So I think we already done this work in this version, and we will need to do this work in later version. Eric, yeah.
Hi there.
Hi.
Eric Voigt. Has there a good customer facing information model? You probably know where I'm going with this. Has there been any discussions or thought about allowing subscription to the customer-facing model on change so that a customer can subscribe to this model and get the changes pushed to them? And are there any I2NSF requirements for Yang push?
Yeah, I think that makes sense. Actually, we have some content in this current draft talking about the telemetry data, because just like what you said, the user need the security controller to send some of the telemetry information from the network or from the security devices, and to do his application. So, but right now, I think it's not, maybe it's not complete, or it's not considered so well. Yeah, I think later we can discuss and add more good work based on the Yang push subscript mechanism. Yes.
At the hackathon this weekend, we had 3 working groups doing Yang push for security functions, and we did a combination of core and netconf and SACM, and we did subscriptions to the Yang models on a router and pulled off security information. So if I2NSF wants to join into that hackathon effort to subscribe to other things, I think that would be useful.
Yeah. I think that's a good idea. Yeah, we can consider it.
SACM, netconf, and core. And again, we have. If you want to learn more, come to netconf on Thursday.
Yeah, I think if we can join, the work from I2NSF can be a complement work to the SACM and netconf Yang, because we are from the security perspective. So yeah, that's a good idea. Yeah, thank you.
Diego Lopez. No, I would like to insist in that I have a concern about calling this an information model. I mean,
okay.
the document. I mean,
Okay, yeah.
I'm not saying that the document has no value, and probably precisely this alignment with Derek was mentioning on this netcom push on from the user point of view probably would help precisely understanding that here probably what we're talking about is about the operations and the operational semantics of the interface, which is not necessarily an information model. I mean, I know the document is a structure around discussing an information model and discussing attributes, but looking at it is essentially discussing operations and discussing arguments of the operations and returns. And I'm not sure, because I'm not familiar with what was done in the hackathon, whether the hackathon was working at the same abstraction level as we are trying to maintain here, in which what you do is that you define, taking into account the capabilities, you make requests related to the capabilities. I don't know if that's the case. But if we're talking about this here, we were talking about operational semantics. I don't know if that would be the best name, but I think that the using information model here is a misnomer, and this is something that we should avoid.
Okay, I understand your concerns. Yeah, I understand. Yeah, in principle, in our I2NSF working group, that we have the consensus that we should have a basic information model, and we should follow those style and those way to define our syntax and our the attributes, anything. So anyway, let me finish my presentation, and we can discuss later on how to organize all this document. Okay. From this picture, you can see that we got a requirement, and what is the information we need from the requirement draft, and then in this version we reorganize the information, the structure of the customer-facing interfaces model, and to follow the ECA model and the capability algebra. So I think that's more consistent now. Okay, that's the main change of the this document, this version. Next page, please. Okay, so that is the current structure of the customer-facing interfaces model. Okay, we have a policy, and the rule policy have several rules, and we have other common objects that defined there and can be referenced by the rule. Okay. And the rule is constructed by the event, condition, and action. So I don't modify any concrete content of every object. I just reorganize the whole architecture. Okay, so that's the current new architecture of this model. Okay, next page. So the later pages, several pages, are all about each object of this model. So first one is event. Okay, we can see that event has event type, which means that it can be admin enforced, or some based on some time control to enforce or some event enforced the event. And we can have some more specific information about what is the time and what is the event. Okay, and next page. About condition. Condition is about what attributes we can use to identify the flow, to identify the service flow. Okay, the source, destination, and the match direction, something. Okay, then next page. Action. Okay, a lot of basic action and more high intelligent actions for the security, because for security devices, there are a lot of actions we can do in addition to the ACR or just some filter something. Okay, and you can see that primary section and the secondary section. Secondary section is mainly for some log, some do more things than just control the traffic. We need to do some log. We need to do some syslog something. Joe?
I guess I'm totally lost at this
Okay.
point. Sorry. Are you proposing that these are all attributes of a new security action class, or that you're adding these attributes to the existing capability action
I think
class?
it should be added to the existing.
Then I would object,
Not new.
because there are some of these are objects, some of these are attributes, and I don't think that all of them are generically applicable. So the problem with the information model, if you do it this way, is that you end up with large, heavyweight objects that people won't use because they don't contain just that information that they want. This is actually a case where using some of the new patterns would actually be superior than making heavyweight classes. This is basically inheritance versus composition.
I think I don't mean that country it's not. We don't say that we must define this in any models. It's just some information that we need in somewhere to do the security service control. It may be in the basic model, or it may be in the inherited in some subclass, right? So it depends on our overall information model way. So we have one capability information model, and then how we construct a more specific model based on those information model. So I think that's a further work we need to consider. So I do not answer right now. Okay. Okay. Next page. And so I think people can, if you are interested, you can take a look at these slides. So other objects include the how to support the multi-tenancy, how to define the endpoint. Okay, we have user group, and device group, application group, location group. That's all the in the high level, in the user friendly level to define the service. Okay. And next page is okay. It's threat prevention. It means that we can get some security feeds from this object, and to help our network security function to decide what happened and what should do. And the telemetry data is about we need to select all kinds of security related telemetry or log informations, and how to organize them to report to the user, to the application. Okay, and next page. Okay, I think in future we still need to do more work to make this model to be more consistent with the work we wish to do in I2NSF. So yeah, still need some work need to do. Okay, that's all.
Thank you.
Okay.
Next one is the consumer-facing data model, Sanji.
Data model, consumer-facing interface for security management.
Sanji, right? Sanji, right?
Hi, this is Seung-Jin Lee from Sungkyunkwan University, and this presentation is for the consumer-facing interface data model. Yes. So in this document, we describe some young data model for the consumer-facing interface between the I2NSF users and the security controller. As shown in the figure, the main objective of the consumer-facing interface is to deliver high-level security policy to the security controller for security enforcement in NSF. So the data model is
required for enabling different users to manage security policy and to deliver the security policy. The data model is derived from the console-facing interface information model. In this information model, the policy is a container of the rules, and in order to express a rule, the rules object must contain the complete information, such as where and when the policy needs to be applied. So this information model defines the set of managed object and their relationships for the complete information about the policy. From our recent discussions between the I2NSF working group editors, we agreed to the point that the information model and data model need to maintain the consistency. Then the information model was revised to reflect the ECA paradigm by adding the ECA submodels in the rules object. So as a result, we had to revise our data model to fully transform the information model into the young data model. So this is updated version. To summarize, we modified the data tree model and young data model for ECA-based policy generation. And we added the XML output for the young data model in use case about the VoIP security service. The data model for the console-facing interface consists of 5 objects: multi-tenancy, end group, threat feed, telemetry data, and the policy. The rest of the data model, except the policy object, have the content of some additional function like the feedback of NSF or some reference data for the policy object. Where in this updated version, our main objective is to reflect the ECA paradigm. So we could modify the policy object to align the semantics of data model with the information model. A policy object is policy object represent a mechanism to express a security policy. So the policy has a list of rule, and for the ECA paradigm, the rule object consists of event, condition, and action. The event is the security event deciding the evaluation of condition. So the event field contains the data for the data to make a decision, the occurrence of security events. And the condition is about how to decide the action will be executed or not. So the condition field contains the data for the decision of action enforcement. And finally, the action is an action like permit, alert, or drop executed when the condition is matched. So in the same context, we also could apply this data model to our use case in the document. So next step, we need some discussions for the consistency between the information model and data model, and the generalization of the data model for more use cases. Thank you.
This is a comment or a suggestion. Thank you,
Yes.
first of all, for your good presentation. It allows me to ask these to make a simple suggestion for your combination with the information model. the telemetry information that you see there may want it to be harmonized with Eric's existing telemetry information because it contains some of the same information. And since we are harmonizing IETF Yang models across the network, it will be something we will discuss in our information model. You might want to look at the, get Eric's information on how to look at that before the meeting.
Okay, thanks.
It will be helpful to you.
Yes.
So I would just suggest that as a thing to do before we do the information model and data model. Thank you.
Thank you.
I guess I'm confused as to why you didn't align with the capability information model.
We are going to align with the capability the information model. And
Why did you not? You said that. Okay, that seems.
Okay, Arnaud Tadei, I have a question regarding one of the former slides. I think is at the beginning, again. Stop here, the one here. So, yes, on this one, you speak about, I see the leg on multi-tenancy.
Yeah.
Sorry?
So I see the box multi-tenancy. And I don't know if the group thought about the multi-tiering aspects and the delegation of administration aspects. Because if I read correctly the charter of that group, you are going to create something which is good for SMB customers and so on. And so you need multi-tenancy, but in effect, it will be managed by many tiers of people.
Yes.
So we'll have various tiering, and it's not the same. Therefore, why I asked the question about the access authorization and the access control as well before. So is this something that is covered by this group or not? I don't know. That's for the chairs. Yeah. Because if not, putting such a model after is hard, is really hard. So you want to look at that as early as possible. That would be my comment.
Do you think we can talk it offline? Because
We can take offline, sure.
yeah, we're really tight on time now.
Cataldo Basile again. I have another question for the chairs, because what I see is that we have several data models. This is okay with my model in religion, but at a certain point into a data model, like the example, the previous example, there is a definition of attributes, primary action and secondary action. This is just an example, but primary action and secondary action is not just a data model. It's changing high-level information. It's a sort of subclassing. This is not exactly okay with my model in religion. But at a certain point, there are several information models. This is a scene, a fundamental scene. And then we have at a certain point, these data models are derived from different information models. And the information model, Draft Kumar, is derived and made compatible with another information model. This is a bit confusing from my perspective. So again, to the chairs, what is the strategy to reduce the proliferation of information models, data models, and strange inheritance between data models and conflicts, so that we don't have to every time discuss about the small details and so we already discussed this, but really, this is not specific to this question. It's just a high-level organization of the information models and all the related data models.
Yes, just want to comment on this. I have observed that people in this working group have different definitions on information model, right? IETF had a draft RFC on what information model is, but obviously many people disagree. That's okay. We don't have to debate here. So maybe we just create a terminology. So information model in academic world is different than like Diego has a really good term like semantics of the attributes to configure, for example, operational semantics. So we can define something like that
Yeah,
to
but then
differentiate.
deriving data models from operational semantics is something that is not in. Yeah. But what,
And let me point out, excuse me, but the terminology draft actually defines information model and data model, but in that definition doesn't use 3444 because 3444 is informational and 3444 references 3198, which is standards-based. So please update the chair slide.
Okay. Okay, so we can.
Yeah, well, this is something that we should solve before increasing the number of drafts that become incompatible because this becomes unmanageable. That's
Yeah, let's discuss that tomorrow. Okay. So unless something just to clarify the draft, and then let's hold it to tomorrow discussion. So we don't have time anymore. So
yeah,
we have 5 minutes left.
Yeah. So obviously we've underestimated how much time we need to request, and we'll take that into consideration in London. Tomorrow, if you're not really interested in the plenary, we are going to have a meeting. Where is that going to happen?
We're going to meet at the IETF registration.
At the IETF registration, and find a place to talk about information models and data models. And with that, thank everybody who's come. If anybody hasn't signed the blue sheets, they're right at the front. And thank you again, and have fun at the social event.
Sorry for the registration draft answer, so we will continue that next time. Thank you, John. It's online.
Yeah, they're online. If you go to the IETF.org main page, there's agenda and meeting materials. Under meeting materials, look for I2NSF. They're all there, including the things that we didn't have time to.
Usually I go to Ethipat to find meeting materials.
There's meeting materials at IETF.org, the main page.
The problem is we have too many people, and their definition of information model is different than IC 3344. So IC 3344, the information model, just to describe what attributes you need. But that's definitely different than some opinion. Maybe we just have a term. Like I think those attributes are very important. If you want to configure an asset, you need to give the attributes, right? Sorry.
Surprise attack.
Well, he's the attack. I'm just saying hi.
Your design team meeting for DM is
Uh-huh.
at exactly the same time when we have the Yang Push design team. So this is unfortunate because the DM was not able to go on the agenda today. We are talking about tomorrow, and we have input to that.
Okay.
So maybe we use the same room.
We don't have a room. Do you have a room?
We have a room.
Butterworth room. We have the actual sign-up room.
You actually have it.
Yeah.
Yeah, I tried to reserve it. I couldn't find it. So do you mind we go there?
No, absolutely not.
Okay.
I think it's a good idea.
Okay.
We can have insular discussions when we are doing our own thing, and we can join discussions when we are talking about the specific Yang
it's probably
data models. And I think that's a good idea because you are the payload.
Okay.
We are building the frame.
And we can also show a demo or two of some security function subscriptions that we did. I can show some of the other demos so you can actually see Yang subscriptions to some of the information.
Thank you.
Yeah, I
Thank
think it's very
you.
important
So what's the
to
name of
align
the
this.
meeting room? Do you know?
Butterworth.
With the small, with the
Small.
for only 12 people.
Yeah, we're only
6.
Butter, B-U-T-T-E-R.
Butter, yes, word, and then W-O-R-T-H.
Butterworth.
Butterworth.
Okay.
And there are only two attendee rooms, a big one and a small one. It's a small one.
Okay. Okay. I
Have it,
changed that to
right.
be Butterworth.
Maybe some of the people will be interested in the demo.
Okay. Thank you
Because it's been
so
a few
much.
times I've come in for saying don't forget yank push, and it makes your life a whole lot easier. And there's already code